evolve the apparatus to breathe dry air, remain hydrated, as well as modify or develop new mental and sensory capabilities to see, hear, navigate, and function in this new habitat. Instead of fins, they needed limbs, and instead of gills, they needed lungs, along with numerous other adaptations and innovations. For those early animals, absent the buoyancy of water, gravity meant collapsing under their own body weight, every whit as much as loss of gravity would mean, among other things, the loss of humans' ability to orient themselves and remain fixed on terra firma. Whereas early animals needed to build strong muscles and skeletons to support their increased weight, humans will have to work hard at maintaining their muscles and skeletal frame due to a loss of body weight. Whereas early animals would have needed new breathing apparatus and over time to trade their gills for lungs, humans will have to develop new breathing apparatus and or carry the air they need in a pressurized spacesuit, spacecraft, or other similarly pressurized surface unit. And whereas early animals faced the risk of drying out due to not being immersed in water, humans will need to carry, find, or produce the water they will need to survive. One of the more successful strategies early animals migrating to a life on dry land developed, and one we seem to have also figured out, was the need to package and carry the water-based environment in which they evolved with them to the new dry land-based environment to which they migrated. This is the reason embryos develop in a liquid-filled womb, why the salt concentrations of both our bodies and seawater are so similar, why our tears and sweat have the salty tang of seawater, and why the proportions of certain chemical elements in our tissues, such as potassium, chloride, and sodium, are not unlike those found in oceans. In fact, it would seem as though animals never truly migrated from the sea, so much as they found ways to take the sea with them onto dry land. Similarly, to survive in outer space and on non-Earth-like planets, modern humans will have to take some of Earth's biosphere with them. Enough of its ecosystems, microbes, air, water, food sources, gravity, and UV ray screens. We are already discovering how living in outer space and on planets like Mars may well engender, over time, a successor human species that would evolve to be more compatible with the new planet. The necessary transition would not be just from one biological form to a more complex one, as from caveman to spaceman, but as explored in Chapter 5 on species-driven evolution, from spaceman to bicentennial man. And the existential event that seems to accompany and even drive such evolutionary phase transitions is already emerging: the impending so-called sixth mass extinction. Here, assembled before our very eyes, then, are all the elements of the next great evolutionary phase transition: a threatening existential event, global warming, which in turn could drive a fundamental change in habitat, an interplanetary migration, which in turn will engender an order of magnitude change in species complexity, and drive the adaptations and innovations to migrate to and survive in this new habitat, outer space or a non-Earth-like planet. The only question that remains to be answered, then, is: what form will the emergent successor Homo sapiens species, if still Homo sapiens, take? And it's both interesting and sobering to consider that most, if not all, the possessions we hold most dear won't be of any use on such a journey. Whether we are wealthy or poor, live in a spectacular house by the sea, or are destitute and homeless, nothing we own will be of any use or value to us at that time. It's quite ironic, isn't it? We will all be starting again from scratch. In this respect, leaving on such an interplanetary migration bears an eerie resemblance to, as we euphemistically say, departing this world. Elon Musk's elaborate plans notwithstanding, one would hope he inspires other moneyed and techno-sapiens. Homo sapiens' interplanetary migration would need an armada of transport systems equipped with a reliable and nearly inexhaustible power source, a continuous source of oxygen and water, waste recycling and disposal systems, and artificial gravity, to name a few. Of course, we would have had to identify a specific habitable planet in the habitable zone of a specific solar system, rocky and Earth-like, preferably uninhabited, and hopefully close enough that the trip would be survivable, measurable in thousands or at most millions of miles or kilometers rather than in light years. And even if we were somehow able to accomplish this, it would be impossible, as Carl Sagan once observed, to transport anything near the number of people born every day. 240,000 when he made the observation, but more than 280,000 today. Let alone the rest of us who got here a few decades ago. In other words, folks, sorry to be the one to break it to you, but just as prior phase transitions of Earth life species to a succeeding one have meant the extinction of most of the extant species, it's unlikely anything more than an infinitesimally small fraction of humanity will be able to escape to an Earth 2.0, even if we found one and were able to get there. Nonetheless, if we do, as our microbe ancestors became symbionts in succeeding microbe species and passed on their genes, nanomachines, and all essential capabilities amassed hitherto, so too humans will pass on, in addition, their store of knowledge and culture that uniquely defines what's human. The genetic information in the DNA of our microbial ancestors will have been augmented with the store of human knowledge and would accompany those who continue on to the next phase, onto other planets. At first, they will be Earthlings, but with time they will become Martians, or will bear the names of the planets to which they have migrated. But even as we still carry in every cell our intestines and other organs, our microbial ancestors, so too they would carry humanity. They will no longer be Earthlings, but they would be forever human. We currently have none of the foregoing capabilities, however, and are unlikely to have anything remotely resembling this level of preparedness for at least another 100 years, if not 200. While it's one thing for our species to have gone from caveman to spaceman in 300,000 years, no nation has had to worry about the preservation of the species and preparing provisions for an interplanetary spaceflight with a large, unspecified number of non-astronauts. And none has had the burden of finding an Earth-like habitat capable of sustaining human life and establishing a sustainable habitat once there. Watching Mars, the television mini-series, would leave one with little doubt that any meaningful interplanetary human migration on a permanent basis is at least 100 to 200 years away, if not more. Accomplishing any of this would be difficult enough, but it would be an entirely different thing to reach the level of global cooperation and trust such an effort would almost certainly demand. And this level of cooperation and trust can come only from first attaining, as a species, levels of maturity several orders of magnitude greater than we have so far managed. While it's not impossible that the necessary innovations and technologies could come earlier, given survival rather than profits as incentive, the survival of our species is unlikely to depend upon technology only. How so? If one considers the worldwide efforts undertaken to address growing climate change issues as a guide to what a potential extinction-driven, interplanetary or intersolar species survival migration effort might entail. One soon discovers it is not a lack of alternative energy technologies or innovative solutions that are delaying the elimination of the world's dependence on fossil fuels. Rather, it is our misguided priorities as a species. More accurately, it is the imposition of the will of the few that leaves us seemingly willing to risk potential habitat destruction and species extinction instead of choosing survival. Essentially, our immaturity and lack of freedom to choose, topics we will get to later. Just getting to anything remotely resembling the unified global effort interplanetary migration to an Earth 2.0 would undoubtedly require could take half a century, if not longer. Other than, perhaps, Hollywood, in movies like Interstellar and The Martian, which at least attempt to explore elements of some of the potential issues, none of Earth's leaders or global institutions appear even remotely engaged in exploring these issues. It's apparently not even on any nation's long-range agenda. Meanwhile, there is another kind of migration, climate change-driven migration, that will preoccupy us long before we have to worry about migrating to another planet. In an October 2018 IPCC special report on the impact of global warming at 1.5 degrees Celsius above pre-industrial levels, a group of scientists convened by the United Nations to guide world leaders describes a world of worsening food shortages and wildfires, and a mass die-off of coral reefs as soon as 2040, and many reading this may well be still alive then. In fact, it claims that the impact formerly forecasted to occur at 2 degrees Celsius are now more likely to occur instead at 1.5 degrees Celsius and by 2040, including inundating coastlines and intensifying droughts and poverty, if greenhouse gas emissions continue at the current rate. Faced with global climate change, what options do Homo sapiens have when terrestrial migration is increasingly no longer a welcome option? The effect of climate change on migration today is complex, both forcing displacement and limiting people's ability to move. Long before the 21st century ends, and as early as 2040, the world could see substantial numbers of climate refugees, people displaced by either the slow or sudden onset of the effects of climate change. The world is witnessing the emergence of a uniquely 21st century phenomenon, the need for migration with no place left to migrate, and the growing tensions caused by people with a need to move to survive in a world with no place else left to go. Yet we live in the era of the greatest human movement in recorded history, writes the Director General of the International Organization for Migration in a 2015 report. In a world with 1 in every 7 persons a migrant, and more people moving in the context of climate change. Over 75 million people live just 1 meter or less above sea level. And the Intergovernmental Panel on Climate Change reports that much of this coastal land may be underwater within the lifetimes of people alive today, placing this population at significant risk of displacement. Current forecasts for the number of climate-induced migrants by 2050 vary between 25 million and 1 billion, depending on climate scenarios, adaptation measures taken, and other political and demographic factors. This estimate would rise if those who cannot move but need to be taken into account. Of the 1 billion climate migrants forecasted, 232 million are international migrants. Nearly 3/4, or 740 million, are internal migrants. People move for a variety of reasons, influenced by economic, social, political, environmental, and demographic conditions. There are also growing numbers of people displaced by conflict and natural disasters. An estimated 50 million are currently displaced by conflict, the highest number since World War II, of which 16.7 million are refugees and 33.3 million are internally displaced people. In addition, there is growing evidence of links between climate change, migration, and conflicts, says a report by the Center for American Progress on Climate Change, Migration, and Conflict. Recent intelligence reports and war games, including some conducted by the U.S. Department of Defense, conclude that over the next 2 or 3 decades, vulnerable regions, particularly sub-Saharan Africa, the Middle East, and South and Southeast Asia, face the prospect of food shortages, water crises, and catastrophic flooding driven by climate change. These developments could demand international humanitarian relief or military responses, often the delivery vehicle for aid in crisis situations. In a world with no place left to flee, some lives have become more equal than others. But one does not get to choose in such a world. The dinosaurs didn't. And it is this loss of the freedom to migrate to survive, at the individual and at the species levels, that has ended prior civilizations and driven prior species to extinction, and that now puts our species at risk. Migration is the species' survival escape hatch, and despite numerous Homo sapiens innovations and adaptations, none has been as effective at moving species out of harm's way as outright migration. How as a species we handle intra-Earth migration might well be an indication of our maturity, and hence ability to deal with the issues of an interplanetary migration. To survive, life must be able to migrate. Migration is an evolutionary survival trait built into our species, every whit as much as the evolutionary compulsion to reproduce. Early humans were comparatively fewer in number, might have been more united as a species, had a vast empty planet before them, and had mostly all that was necessary to migrate. Unlike early humans, we, their descendants, have not yet found an Earth 2.0, don't know where our next home might be, and even if we did, won't have the means to get there for yet another 200+ years. Will we survive? There are some who view these issues with deep concern for our species, and I remind you of the thoughts of one such person we met earlier, the late Stephen Hawking, quoted at the beginning of this chapter. We are at a point in history where we are trapped by our own advances, with humanity increasingly at risk from man-made threats, but without technology sophisticated enough to escape from Earth in the event of a cataclysm. And although the chance of a disaster to planet Earth in a given year may be quite low, it adds up over time and becomes a near certainty in the next 1,000 or 10,000 years. We have less than 100 years to save the human race. In this section, we saw that an intelligent species must evolve in a sustainable, capable habitat, and be prepared to eke out a living in it, as well as maintain that habitat and its species in order to survive. In addition, it must be prepared to adapt, innovate, mature, and migrate to continue to survive, or it will go extinct. The next section explores what else it takes to survive and grow to evolutionary maturity, and what will happen if we don't. Extinction. Part 4. Survival. The reason intelligent species evolved. An evolutionary game of life. Of all the galaxies, solar systems, and planets in the universe that might have become home to our species, evolution apparently evolved and terraformed the Earth, equipped it with a seemingly endless variety of flora and fauna to serve as its life support system. Then 4 billion years later, evolved what may well have been the first collection of nascent intelligent species in the genus Homo, and gave it the same meal plan it gave all other species, an equation of life it must solve to survive. To obtain the energy each must have to survive, a species must figure out how to eke out a living within the planet's habitats and ecosystems without destroying these, other species, and itself. In this section, we encounter evolutionary survival patterns that seem intended to help intelligent species find their way to survival, and a species survival maturity model. Together, they imply rules and goals and suggest that species live out their lives as if competing in a game of life, with survival as the ultimate prize. To survive, an intelligent species must attain evolutionary maturity and reach the survival plateau on the species survival maturity model, that point in its evolution where it has matured beyond its ability to drive itself and other species to extinction. Chapter 12. Survival. The reason intelligent species evolved. The default outcome in the evolutionary game of life. Monarch butterfly caterpillars have evolved the ability to store toxins known as cardinalides, or cardiac glycosides, obtained from their milkweed diet, making them poisonous to birds, according to a study published in Proceedings of the Royal Society B, Biological Sciences. But there are more than glycosides in the monarchs. There is also a message from evolution Homo sapiens can't afford to miss. Like the built-in ability of the monarchs to avoid becoming bird food and to migrate to survive to places like California and Mexico, intelligent species also evolved with the built-in ability to adapt, innovate, mature, and migrate, even to the stars if necessary, to avoid extinction and survive the universe's existential threats. But the monarch butterfly is in trouble. Man-made climate change has intensified weather events, which are impacting monarch populations. Pesticide use is destroying the milkweed that monarchs need to survive. In addition, habitat loss and fragmentation has occurred throughout the monarch's range. And this is the message evolution is delivering to Homo sapiens through the monarchs. You see, like the monarchs, humans are in trouble, and for similar reasons. And because species survival and habitat survival equal Homo sapiens survival, by acting to save the monarchs, we will be taking steps to save ourselves. This chapter explores further what it takes for intelligent species to survive, and claims that survival, rather than extinction, may well have been the preferred evolutionary outcome. The most important question you can ever ask is if the world is a friendly place. Albert Einstein. If one were to rephrase Einstein's question a little and ask instead, is the universe a friendly place for the survival of evolutionary species? The answer, from an Earth life perspective, would have to be yes and no. It depends. Yes, because despite the universe's well-earned reputation for galactic mayhem, chaos, and destruction, its endless cycles of birth, life, and death, there has never been a period in the history of the planet when life has not continuously existed and survived, except perhaps during the late heavy bombardment that took place during the early formation of the Earth, the first 700 million years, when life may have been repeatedly started and wiped out. Nonetheless, life evolved as soon as it was possible and hasn't looked back since. No, because despite evolution's efforts to keep life alive, the universe never seems to stop trying to destroy life. From an Earth-life perspective, how can one conclude otherwise? This chapter explores how evolution might be attempting to solve this evolutionary species extinction problem with the evolution of an entirely new species that it would endow with the ability to mature, survive, and evade the universe's existential threats. Along the way, one finds it hard not to conclude that intelligent species survival, not extinction, must therefore be the preferred evolutionary outcome. The universe's unending cycles of birth, life, and death notwithstanding, evolution found a way for life to keep going once started. By equipping species with the ability and instinctive urge to reproduce, and thereby the ability to perpetuate themselves, evolution was making a clear statement of its intentions. Looked at from the perspective of making a choice between survival and extinction, evolution, it would seem, has always had its feet firmly planted in the survival camp. Not even the major mass extinctions, at least 5, including the mother of all extinctions, the Permian-Triassic extinction, when as much as 95% of all species are believed to have died, or repeated snowball Earth climate change events were able to bring life to an end on planet Earth. And now, 4 billion years and an untold number of extinct species later, here we are, still alive to write about it. Perhaps not even the impending 6th mass extinction, the Anthropocene, believed to be in progress, will end intelligent life on Earth. Since no prior hominin species existed during any of the 5 prior major mass extinctions, it remains to be seen whether intelligent life, Homo sapiens, will be among the survivors, if there are any, of this one. It is not unreasonable, then, in the face of such species survival and continuity odds, to conclude that life, or species survival, appears to be the preferred outcome of evolution, and the default condition of evolutionary species. And if survival is the default, then extinction must be either by choice or by accident. In other words, while species extinctions do occur, extinction is not inevitable. Species evolve and survive until driven to extinction by events beyond their control, or self-extinction occurs, a topic we will have more to say about later. The dinosaurs evolved and survived for about 165 million to 175 million years, and might still be around today if a massive meteorite hadn't rearranged their habitats, jump-starting the series of climate events that drove them to extinction. Had the dinosaurs survived for another 200 million years, it is unlikely they would have evolved to the point where they could have taken action to prevent their extinction. In fact, as of today, if faced with a similar threat, Homo sapiens couldn't. Yet the history of life, at least on Earth, shows that extinction is not inevitable. But is that all there is to life? We spend our years as a tale that is told. The days of our years are 80 years and 10. And if by reason of strength they be 80 years yet, is their strength labor and sorrow, for it is soon cut off, and we fly away. As the psalmist laments in Psalm 90, 9-10 of the King James Version. Is life, and intelligent life in particular, to forever evolve, thrive, and survive, even for hundreds of thousands of years, Early hominin species survived for 900,000 to 1 million years on average. Or tens of millions like the dinosaurs, only to be randomly done in by the universe and disappear into extinction. Or is there something else? If indeed survival is the default condition of evolutionary species, and if indeed evolution is on the side of survival, then one might expect there is more to evolutionary life than we have seen so far. And it would appear there might be. Evolution needed to find a way for life to survive even the Thor-like planetary projectiles the universe might hurl life's way. And it appears to have done so by evolving, for the first time, intelligent species with the innate ability to choose their own evolutionary outcome, and then partnering with those intelligent species to craft a path to their own survival. Species with the latent ability to survive in spite of the random extinction-level events the universe might hurl its way. Hence, to ensure species can survive such existential threats, evolution needed to do more than just continue squirreling away a few species to escape the horrors of the next mass extinction and restarting life over again each time. Evolution needed to equip species with the freedom and the ability to chart their own evolutionary course, to choose to do something the dinosaurs were powerless to do when confronted with an existential threat, to choose to survive rather than go gentle into that good night. It was an evolutionary fork in the road at the species level, a choice that would potentially put 4 billion years of evolution at risk on the one hand, but on the other, if successful, would have the potential to evolve a species that could adapt, innovate, mature, and migrate to survive in a universe ensnared in endless cycles of birth, life, and death. Thus, what with hindsight may come to be thought of as a grand plan evolution had all along, hominins may well have become the first group of species to evolve with the ability to choose its own evolutionary outcome. And now, Homo sapiens, their sole surviving descendant, is left, wittingly or not, to carry the torch on behalf of all prior hominins, to choose what the dinosaurs could not: survival. And yes, as evolution would have it, it will be up to Homo sapiens to choose. Unlike everything else in the universe, it seems, unlike the planets, stars, and mighty galaxies, unlike any other known species, hominins have been endowed with the ability to change evolutionary and galactic outcomes. All faithfully and unfailingly follow the outcomes of the universal laws discovered by Einstein and Newton, and an army of others, laws of physics and of chemistry, and the fuzzy laws that rule the quantum universe. All, that is, except intelligent species, as represented on Earth today by Homo sapiens, and maybe by other intelligent species elsewhere in the galaxy. Galaxies can't choose to go their own way, and for the most part, neither can stars or planets. It takes the sun 200 million to 250 million years to circle the galaxy. And like a high-speed train, this one moving at 500,000 miles per hour, it must follow the tracks and cannot choose a shortcut. The Earth, faithfully following Einstein's laws of general relativity, has no ability to choose to rotate out of the path of another potential death-dealing dino rock to preserve life. But eventually, if evolution gets its way, intelligent species on Earth, maybe even Homo sapiens, one day will. While bound in many ways to the same laws, Homo sapiens has evolved with an innate emergent ability to choose among the many potential evolutionary outcomes possible, within the boundaries of those laws. Homo sapiens can choose to survive, to adapt, innovate, mature, and migrate from one habitat to another, from one continent to another, in time from one planet to another, and eventually, with even more time, from one star to another. If successful, evolution's grand species survival experiment will have paid off, and intelligent species, perhaps even Homo sapiens, will go on to escape the universe's existential threats and populate the stars. But lest we get too far ahead of ourselves, it's useful to reflect upon what survival might mean in a universe with a reputation for galactic mayhem, chaos, and destruction, and its seemingly endless cycles of birth, life, and death. Let's follow the story and discover the ingenious scheme evolution appears to have employed to enable intelligent species to evolve, mature, and survive in such a universe. Given the billions of stars and trillions of planets that pepper the heavens and appear to be perpetually present, it is easy to walk away with the impression that they have always been there and always will be. But we now know that nothing in the universe lasts forever. Not planets, not stars, and apparently not even galaxies. The tale of the universe is a tale of birth, life, and death. A planet forms, survives, even for billions of years. Earth was formed some 4.5 billion years ago and may last another 5 billion. Then gets absorbed into its star as the star ages and expands into the orbits of the planet on the way to its own extinction, sometimes becoming a red giant, as it is believed our star, the Sun, will become. Nonetheless, for a very long time to come, the universe will be populated with similar celestial bodies, as dying stars and planets are continually being replaced by emerging ones. Such was evolution's challenge, to find a way for intelligent species to survive in such a universe. To survive in such a universe, an intelligent species would have had to have the time to evolve on its home world. It must also have had enough time to develop and integrate around a common civilization and cultural survival narrative. It would, by then, have prioritized and developed the technologies, innovations, and abilities necessary to migrate from planet to planet, from one solar system to another, and possibly even from one galaxy to another, to escape the natural cycle of birth, life, and death that characterizes the component bodies of the universe. And it would have developed the innovations needed to avert random celestial shelling, such as what took out the dinosaurs, or occasional supernova or gamma-ray bursts that can fry millions of planets within their kill zones. So even if an intelligent species were to mature past the point of self-extinction, to continue to survive beyond the end of its homeworld, and potentially much, much sooner, it will need to become a multi-planet, multi-star species, as our forebears needed to become a multi-continent species in order to survive. Where once there were seafarers, modern Homo sapiens will need to become spacefarers, planetary and solar surfers, migrating from one planet to another, from one solar system to another. And just as our species, on its way to expanding across the Earth, needed to migrate from continent to continent, crossing mighty oceans, scaling towering mountains, and braving the near-extinction level challenges of the last ice age, adapting and evolving civilizations and cultures, innovating and creating the technologies needed to survive each phase, so must modern Homo sapiens as it embarks upon its own survival-driven migration across the stars. As one reflects on the above, a familiar pattern begins to emerge. Life, and evolutionary intelligent species survival in particular, begins to take on the form of a high-stakes game of survival versus extinction in a universe wherein everything goes extinct unless one can migrate to escape it. It is an unending game of survival-driven migrations, interspersed only by periods of geologic time spent frantically preparing for the next survival-driven migration. Extinction lurks at each transition, like the crocodiles that prey on unsuspecting wildebeests along the banks of the Mara River as they try to get to the grasslands on the other side. The only way to survive is to keep moving, like those wildebeests racing across the Serengeti, like clouds drifting across the skies, like planets orbiting around their stars, like stars around their galaxies, and like fleeing galaxies accelerating away from Earth. Everything in the universe is in a perpetual state of movement and migration. An intelligent species, then, must be able to survive each phase of this game, on each continent, on each target planet, and in each selected solar system. Like contestants in a relay race, with prior generations passing the baton on to succeeding generations. Or perhaps like competing American ninja warriors, an intelligent species must be able to scale each obstacle, cross each barrier, unite, collaborate, and work as a team to strategize how to get to the finish line. In many respects, the species survival maturity model we are about to explore draws on all of these concepts, and may well turn out to be the one game that outgames them all, the evolutionary game of life. By now you are probably thinking, there is one small problem. Someone forgot to tell Homo sapiens about this game of life it's a part of, particularly the rules of the game. But did they? No one told Homo sapiens about Einstein's or Newton's laws, or of any of the laws that led to scientific discoveries about the universe and nature. Yet we discovered them and adjusted our worldview accordingly. We did it because we were curious and wanted to find out whether there was any rhyme or reason to how the universe and life on this planet works, and why we are here. And when we did, we discovered that the universe is comprehensible because its behavior can be modeled. It is governed by what came to be known as scientific laws. And when we found these laws, and the idea that the universe followed consistent principles that one can understand, if not see, we tossed out all those ancient gods we had imagined existed, gods of love and war, of the sun and the sky, of the oceans and rivers and even land, and gods of rain and thunderstorms, earthquakes and volcanoes, and went on to change our values and worldview accordingly. But one can hardly say the same has been done when it comes to what it takes for a species to avoid extinction and survive. It would appear that the laws and patterns that could enable an intelligent species to attain evolutionary maturity and survive beyond the point of self-extinction are now only dimly visible in the social habits of our very distant cousins, such as the bonobos. Scientists consider them the nicest primates on the planet. These laws and patterns have been lost, like the Dead Sea Scrolls once were, perhaps disappearing not long after the transition to agriculture, and they may have remained hidden since then. Whereas science has dispelled the fog and superstitions that once dominated our worldview and understanding of nature and the physical universe, it seems no similar effort has been exerted to discover the laws and patterns that evolution must have left to guide an intelligent species along the path to survival. In this arena, some of that same fog along with multiple superstitions, still imprisons our thinking. We remain uncertain and open to religions, philosophies, belief systems, and competing theories about how life should be lived. We have succumbed to ways of living and seeing the world that have led mostly to the collapse of earlier Homo sapiens civilizations. And there is potential for yet another collapse, this time on a global scale. Homo sapiens, it would seem, failing to comprehend what it takes to engage with the universe's evolutionary survival mechanisms, perhaps failing to even recognize the presence and possible purpose of evolution's continuing role in species survival, has proclaimed a kind of eminent domain over all the earth and its contents, and has declared itself Lord and Master of all its surveys. And like that 4-year-old with a hand grenade we met earlier, now a full-grown adult, our species is intent on wrecking and destroying all for what it wrongly perceives as existing exclusively for its own benefit. But what if there is a different way? As different as scientific laws are to superstition and mythology? Is it possible that just as evolution has left clues to the workings of the physical universe and nature, it has also left clues, like breadcrumbs, to help intelligent species, like Homo sapiens, discover how to live to survive, rather than blindly blundering into, or worse, consciously and perversely choosing, paths that can only end in extinction? Those clues and survival breadcrumbs are strewn about over geologic time, so intelligent species looking back might find them. In previous chapters, those clues were identified as species survival patterns, and in this chapter, they are brought together to build a potential species survival maturity model, a model that might well be a potential survival framework, a manual for how to succeed at this game of life, that evolution left an intelligent species, like Homo sapiens, to follow if it chooses to survive rather than go extinct. Indeed, self-extinction was never going to be a problem for non-intelligent species like the dinosaurs. Never mind how many more millions of years they might have survived. And perhaps that's why cockroaches and beetles are still around, despite multiple mass extinctions. Self-extinction is a disease only an intelligent species can catch. The purpose, then, of this game appears to be to get intelligent species to mature and survive beyond the point of self-extinction, which implies that self-extinction is the greatest threat to intelligent species survival. It's helpful to think of this model, figuratively, as the Earth encircled by a continuously ascending ladder that, like lines of latitude, begins at the bottom and continues all the way up to the top, as in the figure below, with numerous horizontal rungs, or circles. Each rung represents a level of maturity, and there are as many of these as necessary, 8 rungs are shown, to enable an intelligent species to climb all the way to the top rung, the survival plateau, that level of maturity whereby a species has passed the point of self-extinction. Rungs on the ladder represent the geological intervals when an intelligent species might exist, and during which it must choose to mature and migrate to the next higher level to survive, or go extinct. Each rung serves as a kind of sieve, a winnowing out of intelligent species that results in the survival of evolutionarily maturing intelligent species and the extinction of persistently immature ones. Intermediate rungs seem intended to drive intelligent species to higher and higher levels of adaptations, innovations, maturity, and migration to survive, or to extinction. There appears to be no half measures here. An intelligent species must be able to get to the next higher rung to survive, or else it will go extinct on the current rung. This model certainly leads one to wonder whether this could be the reason Homo sapiens remains the sole surviving intelligent species in the genus Homo today. The surviving species that eventually make it all the way to the topmost rung, the survival plateau, will have survived beyond self-extinction and will be well positioned to embark upon what seems like a follow-on stage of evolution, extraterrestrial intelligent species evolution. Hence, to win at this game of life, an intelligent species has to continue to mature and survive all the way to the top rung, beyond the point of self-extinction. To understand this model, one must begin at the bottom, or first rung. It houses the following set of initial conditions that must be met for an intelligent species to have a chance to compete, let alone mature and survive beyond self-extinction, and includes life. Members of a species must, of course, have evolved and be alive to have any chance at surviving, including an ability to remain alive, and as much as is possible, stay clear of extinction-causing events. Location. Survival may well depend on location and location-dependent survival issues, including where in the galaxy, what else is in the galactic neighborhood, on which planet, what kind of star, whether that planet is orbiting a star with a continuously habitable zone, and whether the planet is in the star's continuously habitable zone. The seeming rarity of Earth-like planets able to sustain complex animal and intelligent species life may be among the reasons scientists are starting to suspect that while microbial life in the galaxy might be common, complex animal and intelligent life might be rare, and might be one explanation for why we have not been able to communicate with other potential intelligent species. Timing and just plain luck. Perhaps more than one might have thought, timing and luck may impact survival more than smarts. Life may have evolved and been annihilated repeatedly during the late heavy bombardment of Earth's early history. Timing may well have been on the side of our forebears as they left Africa much later than other hominin species, whose earlier departure to Asia and Europe exposed them to the worst of the last ice age and may have driven them to extinction. By departing much later, Homo sapiens might have encountered much lower water levels in the Red Sea when they migrated. Timing may be another reason we haven't encountered other extraterrestrial intelligent species, and might also be one reason Homo sapiens are around today and not the dinosaurs. Reproduction. Evolution appears to favor survival. An intelligent species must not only first exist, but must be capable of reproducing itself and growing its numbers to enable continued survival. A species' ability and innate desire to reproduce is a cornerstone of this evolutionary survival pattern, and does not depend upon the consent or volition of individual members comprising the species. Habitat viability. Habitat viability and species survival are inseparable. An intelligent species must have evolved at an auspicious time and place in the galaxy, on a planet in a solar system capable of evolving and supporting complex animal and intelligent life, and in a sustainable capable habitat such as Earth provides. The evolutionary survival pattern appears to be habitat first, emergent life second. Habitats are sustainable capable, but must be continuously maintained to remain sustainable. An intelligent species, having evolved, must continuously maintain its habitat, as its own survival is inextricably intertwined with the habitat's continued sustainability. When a habitat fails despite an intelligent species' best efforts, the species must be able to migrate to another habitat, or it will go extinct. Adaptation, invention, and innovation. An intelligent species must have the ability to adapt, invent, and innovate to survive. Survival-driven adaptation and survival-driven innovation are closely associated and comprise another of those species' survival patterns. While the ability to adapt and innovate is necessary, adaptations and innovations are by no means sufficient to ensure survival. Survival and migration. Survival and migration are inseparable. A species must be free, able, and willing to choose to migrate to survive. Survival-driven migration is as native to a species as is its urge to reproduce. Migration is an evolutionary pattern, and species perish when the opportunity to migrate no longer exists. The next intelligent species-wide, survival-driven migration will be interplanetary. With no place else left to go, unless or until Homo sapiens finds a way to occupy the remaining 70% of the Earth's surface now covered by its oceans, it is more than likely that when faced with an existential threat, the next great Homo sapiens survival-driven migration will not be from Africa to Europe, but from Earth to another planet. However, by some estimates, it could take from 100 to 200 years before Homo sapiens will have acquired the abilities necessary for interplanetary or intersolar migrations. Maturity. To survive, an intelligent species must be willing, at each rung, to prioritize and pursue evolutionary maturity over all else. An intelligent species' survival may come down to its attainment of evolutionary maturity. Even if it's able to clamber up all the other rungs of the species' survival maturity model, its survival may well come down to its ability to mature. Survival and maturity form a yin and yang evolutionary survival pattern pair. An intelligent species must mature to survive, and must survive to mature. Evolution appears to have placed attaining evolutionary maturity, both at the individual and species levels, as the final rung on the maturity model, the survival plateau shown in the model above. To survive, a species must be able to respond to its better angels, or extinction is inevitable. But maturity does not come easily. Unlike species survival through reproduction, where continuity of the species appears to be almost autonomic, if not instinctive, species survival due to evolutionary maturity is not. And just as species